Hello class, so in this section we're going to be looking at a variety of things. We're going to be looking at end behavior of a function. We're going to be looking at increasing and decreasing intervals of a function. And we're also going to be looking at average rate of change of a function between 2 points. So let's start off with end behavior. You know, when we have a graph, the graph only shows visibly this piece of information right in here, and we don't know what really happens out here. And so end behavior is a description of what is happening to the functions, i.e. the y value, at both the left end and the right end of the graph. So when I mean the left end of the graph, what I mean by that is what is happening as x moves more to the left, as x becomes more negative, as x goes to or approaches negative infinity. And that's what this symbol right here kind of means. X approaches negative infinity, or x goes to negative infinity. Now on the right hand side, in a similar way, what is happening to the function, what is happening to y as x goes to positive infinity? So let me give you some examples of this. A couple graphs here. So let's first look at the left-hand behavior as x here goes out to negative infinity. The function, so I could be tracing along here. X is 0, and it's getting more negative. X is getting more negative, and the y value here is now shooting up to positive infinity. So we say f of x goes to positive infinity as x moves to the left to negative infinity. And on the right hand side, as x becomes more positive, so we start at 0, x is increasing, and the y value is actually decreasing. F of x goes to negative infinity. In this graph over here, as x goes to the left, we notice f of x goes down to negative infinity. And we notice as x goes to positive infinity, the function goes down to negative infinity. So note that sometimes end behavior is not always plus or minus infinity. Sometimes it can be a specific number, or sometimes it just does not exist. So in this example here, you notice here, this is called an asymptote. An asymptote is not part of the graph itself. I mean, the graph of the function is a solid line, but the asymptote provides a lot of good information as to the behavior of the graph. So we note here that as x goes to negative infinity, you know, we could follow it along the graph as x goes more and more negative. What the asymptote is suggesting is that the function f of x approaches, gets very close to the asymptote, although it never actually touches it. It doesn't cross it either. So f of x goes to -2 when x becomes really negative. Now I just mentioned just a second ago that the function, as it goes over here, it does not cross the asymptote. But over here we do show that it crosses the asymptote, and it's absolutely legal for a function to cross through this horizontal asymptote. But as it goes out over here, the way we understand this is that it does not cross the asymptote here. As x goes to positive infinity now, we see that the function goes up to positive infinity as well. Now in this case, we assume that this sinusoid shape continues on forever and ever, and so as x goes to negative infinity, because of the oscillating nature of the function, it does not have a specific number we can say it ends up at. We say there is no end behavior. It does not exist. And the same thing is true on the right hand side as well. Does not exist. So that's end behavior. Fairly simple concept. Okay, increasing and decreasing regions of a function. A function is defined to be increasing when the line that is tangent to the function has a positive slope. So for example, here's my function. Say I want to find out, is it increasing or decreasing at this point? I will then create a tangent line to the graph at this point, and if it's a positive slope, we say it's increasing, whereas if it's a negative slope, well, that's not really tangent, maybe something like that. If it's a negative slope, we say this is a decreasing area. And it's just as if you're riding a roller coaster down from the left to the right. We're going down the roller coaster, up the roller coaster, down the roller coaster, up the roller coaster, and down the roller coaster. So decreasing when the tangent line is negative sloped. So we're going to specify the intervals of increase and decrease here. And when we specify the intervals, the key idea here is we are talking about the x interval, where in terms of x is the function increasing. So we can note here that we can color it. We could color the portions of the graph where we have an increase of the function, and we are now specifying in interval notation the x regions. So we're going to specify from -4 up to 1. That's one interval right here. And then we have the other interval over here from 3 to 6. So we use the union sign to say the set of all numbers between -4 and 1 in addition to this set of all numbers between 3 and 6. Likewise, we do the same for the decreasing regions, and in this case we have 3 regions from -infinity to -4. Again, we're talking strictly x, x values. What are the x values upon which the function is decreasing? So then we have this other interval from 1 to 3 where it's decreasing, and the other interval lastly from 6 onward. Okay, so that's the idea of increasing and decreasing functions. Last concept, we're going to talk about average rate of change. So in this case, the average rate of change between any 2 points of a function is merely the slope of the line between those 2 points. So, for example, I have my function here, and if I say, what's the average rate of change between of the function between x values a and b, I want to find the points up here at f of a and f of b, and then I'm going to draw a line between those. The slope of that line is what we call the average rate of change. The function is changing basically. It's actually going down and then it's going back up, but the average rate of change will be the slope right here. And we just use the slope equation. It's going to be f of b minus f of a, the change in the y divided by the change in the x's. So here's an example. Given a simple function, x squared, what is the average rate of change between the x values of 1 to x, or from 1 to 4? And you see the interval notation right here. So what I want to do is I want to find the slope between 2 points. I'm given the x values. The x values are 1 and 4, but I need to find the y values. And so all I'm really doing is plugging 1 into the function and plugging 4 into the function to get the y values. So now I have 2 points and I want to find my slope. So visually this is what's going on. I have the x squared function. I want to find the rate of change between this point at x is equal to 1 and this point at x is equal to 4. So then I just put it into my slope equation. Change of y divided by change of x. And my slope is 5. Okay, so I just have some problems for you to do. I'll show the answers in 3, 2, 1. Next page. This may not be in your notes, so make sure this is in your notes. Describe the end behavior. I'll show the answers in 3, 2, 1. And you notice here, I said there is no end behavior because the function does not have any value at x is equal to negative infinity. You know, we could write this, that as x approaches negative 4, f of x approaches negative infinity. That works okay too. It does describe the end behavior of this particular graph here, but you know, specifically we say the end behavior is what happens at positive and negative infinity, and there is no behavior of the function at negative infinity. Okay, that's the lesson for today. Have a good day, class.